Good morning, guys. Happy Tuesday. Let's get into it. We got the part two of your test review today. We did part one yesterday. It was a little bit longer video. This one should be a lot quicker. This one's not very long. I'm going to try to move fast through this one. You got your test I'm going to be releasing today, and that's all you're going to have this week. So you've got a review yesterday, a review today. I'm going to release the test today. You can do it. Doesn't matter. I just need it done ASAP. I'm going to have that done and up a little bit later because I got to put it in forms. But I'll be on like normal, 9:30 to 10 every day. If you guys have questions, if not, you do not have to show up. Some of you guys said that you can't see this documents that I have on the PDFs. If you don't have a PDF viewer, you have to get one. Otherwise, you should pull up on a web page. And if you can't view it, worst comes to worst, guys, you got to be problem solvers here. I'm showing you the paper right here in the video. There's no reason you can't see this. Just write down the problems. Okay? Now write down the answers to problems. Pause the video right here. Start doing some of these problems. Wait for me to solve a couple. Check them. There you go. All right? So I'm going to go ahead and start here. Problem number one. What is the range of this set of data? The range of the set of data is the distance from the lowest to the highest number. The lowest number is 20. The highest number is 130. So the range of the set of data is 110. We're going to find the mean, median, and mode. I'm going to pull up a calculator for this real quick. So I can pop this over here for you guys. And we've got, in our dot plot here, we've got two 20s, 50s, three of them, 1, 2, 3, 4, 5, 6 60s. So it's 360. I just that in my head. 370s, 480s, 490s, 200s, and a 130. We divide that by how many total numbers we have? 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 25. So we got 70.8 for the mean. The median is going to be that middle number, um, which we're going to count off dots on either side until we get into the center, which is how we do it with our dot plots. So one off either side. We just keep counting towards the middle, and it looks like right there in the middle, the very middle number is going to be 70. So our median is going to be 70. It's really close to our mean as well. And our mode is the number that shows up most often, and that's going to be 60 here. So there's our mean, median, and mode for the set of data. Let's move on to the next question here. Find the mean for each of these sets of data. The mean for the cost of tennis shoes, the average cost of tennis shoes here. Looks like we got 57, 63, 60, 59, and 61. The average cost looks to me like it's going to be right around 60 bucks. Looks like all of those shoes are around 60 bucks, and that's what should happen when we go to find the mean of the set of data. So let's see, we've got a 57 plus a 63 plus a 60 plus 59 plus a 61. We add all that up and we divide it by how many shoes there are. 1, 2, 3, 4, 5. And you get 60. Check that out. Mean is $60 there. Number 4, age of students' dogs. We clear this out. One of them is 5. One of them is 6. One of them is 3. One of them is 4. 8, 10, and 6. We add all those up. There are 1, 2, 3, 4, 5, 6, 7 dogs. Did I hit the divide by button? 6. Looks like the average age of these dogs is 6. Number 5. Weights of cats at a pet store in pounds. Again, finding mean is the average. Let's add them all up and divide by how many numbers we have. It's 5 plus 4, 10, plus 7, plus 6, or a total of 32. And that's going to be divided by 1, 2, 3, 4, 5 cats. Looks like the average weight of the cats there, 6.4 pounds. Cost of DVDs. It's so crazy to me how a book this recent can make questions like this. Where they're talking about the cost of DVDs. And DVDs are so much more irrelevant these days than what they were literally like 2 years ago. That's wild to me. Anyway, DVDs here. Cost of them. $10, $5, $19, $25, and $15. Add all those up, you get 74. But you take that and divide it by how many DVDs there are. 1, 2, 3, 4, 5 of them. The average cost of those DVDs, $14.80. Let's go ahead and swing on down here to the bottom of the page. Hopefully you guys are doing pretty good with this. I like questions about average and mean. Down here at the bottom for questions 7 through 9, we're going to use the following set of data. The temperature in Georgia was recorded for 6 days in November. Temperatures were 62, 60, 70, 78, 60, and 66. That's a total of 1, 2, 3, 4, 5, 6 pieces of data. It says what is the mean for this set of data? Okay, for the mean, all we need to do, add all the numbers up and divide by how many there are. But I'm going to do this first. Whenever they start asking me questions about data, the first thing I want to do is probably put it in order from least to greatest, because I know they're going to ask me for median and mode down here in questions 8 and 9. So I'm going to go ahead and do that. Find the lowest number here. Looks like it's 60. And then there's another 60. We have a 62, a 66, a 70, and a 78. Okay, so the mean, we're just going to add all these numbers up and divide by 6. When you add all those up, you get 396. Divide that by 6. Looks like the average temperature for those days in Georgia was 66 degrees. And one thing you should do when you put these answers down, remember we talk about checking for reasonableness all the time, guys. Does that look like a temperature that fits for Georgia during those days? So if we look at these temperatures, looks like we're between 60 and 78. Looks like our temperatures are in the 60s. 78 is kind of the one that's sticking out a little bit, that's a little bit higher than the others, but the rest of them all look like they're between 60 and 70. So if I told you that the average temperature in Georgia was 66, would you agree? I would. I think that's a great, reasonable answer. So I would put that down. Even if I made a mistake, I still feel good about that one. Number 8. What is the median of the set of data? The middle number. We have 6 numbers. That means that there is going to be no middle number. Right? It's going to be right in between 62 and 66. Now the best way, you could technically just give me the number that's right in between 62 and 66, and that is 64. But if you're not sure, all you have to do is go to your calculator, add those two middle numbers together, 62 and 66. 62 plus 66, and then divide that by 2. And there you go. Your median, 64 degrees. And again, remember, these are measures of central tendency. Again, 64. Right in that range of a temperature that seems like it would be a good median. Mode, the number that shows up most often. Well, clearly, there's only one that shows up most often, and that is 60. There you go. And that takes care of that front page. We're going to hop over to the back here. We only have 2 more parts here for measures of variation, and we'll be done here. Number 1, we're going to find the range of this set of data. The first thing we're going to do is put these in order from least to greatest. And we've got a lot of numbers here, so this might take me a minute. Looks like my lowest is 132. And then 237. Oh, no. I've got a 183 and 191. 183. 191. Then my 237. And then my 251. And then my 277. 279. 334. 448. And 599. Range of the set of data is the distance between the lowest and highest number. So all we have to do is take the highest number and subtract the lowest number. The distance between those is 467. Median and first and third quartiles. Median is going to be that middle number. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers. So it's going to be 1, 2, 3, 4, 5. It's going to be right in between these two numbers, 251 and 277. And just like the last problem we just did, we're going to add those numbers up because I don't know exactly what's in between them. So we'll go 277 plus 251. Get 528. Divide that by 2. Your median is 264. So we'll say the median 264. And now we need Q1, which is going to be directly in the middle of that. So the middle of the first 5 numbers is going to be 191. Right there. Q1. That's the median. And then Q3 is going to be the middle of the last 5 numbers, which is right there, which is 334. The interquartile range. Again, remember, range is distance between two numbers. That's going to be the range between Q1 and Q3. So we will subtract 334 minus 191. Gives us 143. Outliers from the set of data. Looks like we've got one outlier in the set of data, and I would say that outlier is 599. I think that down here on the lower end, 132, 183, 191, all these numbers are pretty close together. Kind of gradually raises up to the hundreds, the 200s, up to the 300s. And then we really make a big jump after we get up to 599. That's about 150 away between these two numbers here. Although it's a pretty big jump from 334 to 448, it's a really big jump from here to here. So I would say that 599 is an outlier in our set of data. It's just a little bit too far away from the other grouping of numbers. And let's hop down to our last section here. And it's going to ask us the same questions. So we're going to put these in order from least to greatest. Looks like our smallest number here is 1.49. Now, although these are decimals, we treat this the exact same way. Now, if you have calculators, you don't have an excuse now, guys. This should be pretty efficient if you got a calculator handy. We're going to go 1.71. The tricky part is getting these numbers in the right order. 1.72. 1.89. 1.92. 1.93. And up along, right in order from least to greatest. I think the next one is 3.56 here. And I think 3.8 is the next one. And then we start to go a little bit higher here, and we get 7.34, 8.23, and 8.62, and then finally 9.89. I believe that's all my numbers, and I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 of them. I'll just make a little note there that I have 12 numbers. 12 monthly precipitations. Okay, let's start answering these questions. The range, the distance from the lowest to the highest number. 9.89 is the highest, 1.49 is the lowest. 9.89 minus 1.49. Boom. The range 8.4. The median, we have 12 numbers, so it's going to be between the 6th and 7th numbers. It's going to be right there, just to be sure. It's between 1.93 and 3.56. Now this is a great example of one where you just can't do it in your head, right? I can't figure this one out in my head. I'm sure there's some of you out there that might be able to, but I'm going to have to add these two together and find the average of them. So I'm going to put 3.56 plus 1.93. It's going to be 5.49. I'm going to divide that by 2. And my median is going to be, and I'm going to round this to nearest hundredth because all of these are rounded to the hundredths, I'm guessing. So I'm going to say that this is, the median is 2.7, and then that 5 right there is going to tell us to round that 4 up to a 5. So this is going to be 2.75 for our median. Now we need Q1 and Q3. Now for this one, this is also pretty interesting because we now have 6 numbers in the front half. So that's an even number as well. So we're going to have to do the exact same thing we just did to find the Q1, which is right in between 1.72 and 1.89. So I'm going to do the same thing again. 1.72 plus 1.89 and divide that by 2. And we get 1.805. And again, we can round that. 1.81 for our Q1. We'll do the same thing to the other side over here. The 6 numbers. It's going to be right in between those 2 numbers for Q3. So we are going to add up 7.34 plus 8.23. Divide that by 2. And the average of those two is 7.7, and that 5 is going to bump that 8 up to a 9, 7.79 for Q3. The interquartile range, now that we've found those, is the distance between Q1 and Q3. So all I have to do is subtract them. 7.79 minus 1.81. Our interquartile range is going to be 5.98. And then we're going to look for any outliers in the set of data. So any numbers that just don't look like they belong to the rest of them. And technically, if we were looking at outliers for the set of data, earlier in the chapter we talked about, or I had mentioned that I wasn't going to show you guys the exact way to find mathematically an outlier, and that is adding the interquartile range to the median to determine if a number is an outlier or not. And technically, 9.89 would be an outlier, but looking at the general trend of the data here, we've got a lot of numbers down in the between 1 and 2, a couple in 3s, and then we jump up to 7, and then 8s. There's 2 8s and a 9. I really don't think that 9 is too big of an outlier. You can make a case that it is or that it isn't. Mathematically speaking, it would be, but I would just say, for our general purposes, there are no outliers here. Nothing that really jumps out at you as being too wildly outside the set of data. And I'm not going to be too crazy with these questions on your test. This one, definitely a difficult one. You guys know how I like to give you more difficult questions on the study guides than I do the test. Just helps you prepare better. And I'm a nice guy. Okay. That's it, guys. If you got questions, let me know. Please, really hope you're using these videos. Peace out.